So welcome back to my channel. So for this video, we look for the effect of a constant p and q affect the function and how these two constants affect the function. So we have these cases when we have y equals x squared plus q. So how would the constant q affect this function? And also how would the p in this function affect the function? So we are going to look for these two cases in this video. So basically we have the first condition, y equals x squared plus q, and I'm going to look for how the q here affect the function. So I need to set up two hypotheses when q is positive and when q is negative. So here is what you learn from school. So when q is positive, the function transforms q units upwards from y equals x squared. So given that we have y equals x squared, basically I just move the y equals x squared q units upwards depend on this function, this constant here. So when the q is negative number, the function transforms q units downwards from y equals x squared. So given that we have the y equals x squared, we actually transform the function downwards, right? So basically when q equals to 3, the function transforms 3 units upward, and when q is equal to negative 3, the function transforms the 3 units downwards. The left picture here I show you the three functions here. So we have the black curve, the basic function, y equals to x squared, and we also have the red curve, y equals x squared plus 3, and the green curve, y equals x squared minus 3. So in order to draw the y equals x squared plus 3, I need to shift everything up 3 units based on the y equals x squared curve. When I graph the y equals x squared minus 3, I need to shift the y equals x squared graph downwards 3 units. So everything is downwards 3 units. So how the constant here affect the function? So basically affect the y values of function, right? So the range is affected and also the vertex is also affected. So at first we have 0, 0. So for y equals x squared plus 3, we have the vertex at 0, 3, right? So the lowest point is at 0, 3. And also for a green curve here, the lowest point, the vertex is at 0, negative 3. And it also affects the range of the function. So for the basic function, we have y greater or equal to 0. For the red curve, we have y greater or equals to 3. So everything is greater than 3. And for the green curve, y is greater or equals to negative 3. So basically shifting the graph upwards or downwards doesn't affect the domain of the function. So the domain is all x values. So what about the axis of symmetry? So remember, the axis of symmetry is the point where we can separate two graphs. So basically, at x equals 0, we can separate the graph from left-hand side and the right-hand side, and it makes the graph symmetry. So basically, the axis of symmetry also stay the same at the y-axis. So x equals 0 is the y-axis equation. This is a summary of what I just said. So basically, a domain and the axis of symmetry doesn't affect, but the vertex and range affect when I shift the graph upwards or downwards. So next I want to cover the y equals x minus p squared. So remember the p, the constant, is inside the bracket, it's not outside the bracket. And the constant p is positive, the function shift p units to the right from y equals x squared. When the constant is negative, the function shift p units to the left from y equals x squared. Pay attention for these examples. So we have the x minus 2 squared, the constant is greater than 0, so it's positive. So basically when the constant is positive, I expect to see the sign here is negative, right? So when this is negative, right? So I need to expect to see the sign here is positive because the negative sign cancels out and turns this to positive sign. So we have x plus 2 squared. So in the picture above, I show you three situations, y equals x squared in the middle, and y equals x minus 2 squared in the right. So remember when I graph the y equals x minus 2 squared, I need to shift 2 units from the right from the y equals x squared. When I'm graphing x plus 2 squared, I need to shift the y equals x squared 2 units to left and get this green curve. So basically how the constant here affect the function y equals x squared. So basically the vertex is different when I shift the curve 2 units to the right, 2 units to the left, right? So we have the vertex at the right here, 2, 0. When I shift 2 units to the right, when I shift 2 units to the left, the vertex is negative 2, 0. So it also affects the axis of symmetry in this situation. So how can we find the equation of the axis of symmetry? Basically, the axis of symmetry actually pass through the vertex of the red curve and of the green curve. So here we can see that the equation of axis of symmetry equals to x equals 2 for the equation in the right hand side, and for the left hand side we have x equals minus 2 for the green curve. And for the black curve, we have this one as my axis of symmetry, x equals 0. So basically the constant here affect the vertex and the axis of symmetry, but it does not affect the domain and range. So when you want to figure out the axis of symmetry, you need to do x equals the x value of the vertex. So for the green curve, x value is equals to the vertex x value, so which is negative 2.